When using Table I, you can find the heat of reaction of specific equations. And this equation, I've left out the phases of matter, but sometimes those are really important too. For this one, when you find it, you're going to see that the reaction is right here, and the heat of reaction is listed off to the right here. It's negative 84.0, and that is measured in kilojoules. So what that's telling us when it tells us negative is that the heat is being released. It's an exothermic reaction, so it's one of the products, 84.0 kilojoules. What they could do to you, though, is give you an equation like this. And you can look all day in that table and you're not going to find that exact same equation. But if you look carefully, it's actually this equation written in the opposite direction. So, oh, I'm sorry, I circled the wrong one. So it's this equation. Here's now a reactant. These would normally be the reactants, but they are now the products. So when that happens, you take the heat of reaction and you just change the sign. So all you're doing when the reaction is flipped, you're going to flip the sign. So this one's negative listed here in this direction. So in the direction we have it, it would be positive 393.5, which means that heat is one of the reactants. There's one other thing they could do to you. Instead of giving you the whole equation, they could say, you know, what's the heat of reaction for the formation of, and then give you that. So let's do one of those. So if they ask you for the formation of ammonia gas, you're going to be looking for that on the product side of a reaction. And here it is right here. But there's something else you need to notice. This reaction is written for producing 2 NH3 gas, or 2 moles of that, which we'll get into soon enough. So you have half as much if you're only making one of these. So we look at our heat of reaction, which is 91.8, and we're just going to cut that in half. So the heat of reaction for the formation of 1 mole of NH3 gas, or half of what you would normally make, would be negative 45.9 kilojoules. So instead of just flipping the reaction like we saw in this example, they could just give you the product and ask you to come up with the heat of reaction. And if they give you half the amount, then you just need to have the heat of reaction.